From the world's largest telescope to a nuclear fusion reactor, which might just be the most complex machine ever built. I'm Regis, and today we're taking a look at the most complex megaprojects the world has ever seen. Are you ready to step into the future? Our journey starts with the ELT. Those letters stand for Extremely Large Telescope. It isn't the most inventive name, but
I was about to say something about that, but
it's
let's just let
definitely
him
an
cook.
accurate description. At the moment, this project is halfway finished. It won't be ready to use until 2027, but it's already clear that this extremely large telescope will be, you guessed it, very large. A telescope works by using
very large.
curved mirrors to collect light from distant objects. The mirrors focus that light into a single eyepiece or camera. The bigger the mirror, the more light it can collect, and the further the telescope can see. And that's where the ELT is doing something truly groundbreaking. The ELT's main mirror will be 39 meters across and weigh in at approximately 132 tons. To put that into perspective,
Damn.
the largest telescopes that currently exist use 10-meter mirrors. In other words, the ELT's main mirror will be 4 times larger than anything that's been built before. And that's just one of the ELT's mirrors. There will be 5 in total. The other 4 are smaller though. 2 of them approximately 4 meters wide, and 2 of them are just under 3 meters wide. By working together, these mirrors will collect more light than 15 10-meter optical telescopes combined. In other words, these mirrors will allow this telescope to look farther than we've ever looked before. And that's not all. These mirrors will be fully adjustable, with one of them actually thin enough to bend its shape. This will allow them to focus on objects at an incredible level of precision. An astronomer could tweak the position of these mirrors by a centimeter or a millimeter, or even by tens of nanometers, a measurement approximately 10,000 times thinner than a single human hair. The telescope's mirrors will be encased by a dome that can open and close just like an eyelid. This will help to protect them from bad weather. Not that bad weather should be too much of a problem. The site of the telescope on a desert mountain in northern Chile was specifically chosen because the sky is so consistently clear. Almost 90% of the nights at this location are totally cloudless, making it the perfect place to use a telescope. There's also very little light pollution, with no nearby cities or towns. The ELT isn't the first to take advantage of these conditions.
The
A few
ELT,
kilometers
bro.
away, the VLT, or Very Large Telescope, is already active. There are also plans to build another project, the Giant Magellan Telescope. It won't be quite as large as the ELT, but it'll come pretty close. The ELT will have 2 main functions. First, it'll be used to study galaxies that formed in the aftermath of the Big Bang. This is possible since the ELT allows a deeper exploration of our universe than any other telescope before. If it can be used to work out how old these galaxies are and how exactly they formed, it could give us more precise answers about the age of the universe as a whole. Another question that the ELT is trying to answer is whether we're alone in the universe by studying far-off planets. It'll take photos of these planets with incredible detail, allowing scientists to work out if any of them could potentially be home to life. Once the ELT is ready to use in 2027, it could massively change what we know about the universe so far. With the ELT, we could spot the planets around Proxima Centauri, the nearest star to our sun. The ELT could also become the first tool to find evidence of life in other solar systems. But space isn't the only place where humanity is pushing the boundaries of technology. Next up, we turn to the ocean with a project called System 03 from the Ocean Cleanup. In the distant past, the ocean was clean and pristine. But over the last 100 years or so, millions of tons of plastic waste have accumulated in the water. The most staggering example of this plastic pollution is known as the Great Pacific Garbage Patch, a giant patch of floating garbage right in the middle of the Pacific Ocean. This garbage patch is colossal. According to a survey in 2018, it covers an area of 1.6 million square kilometers. In other words, it's 3 times the size of the country of France. And the patch isn't getting any smaller. The same survey estimated that the Great Pacific Garbage Patch was getting 10 times bigger every decade. But maybe that's about to change. The Ocean Cleanup is a Dutch nonprofit that's working on a way to take down the Great Pacific Garbage Patch. In 2018, they constructed a project called System 001. In simple terms, it was a U-shaped barrier that floated on the water with a 3-meter skirt hanging down below the surface. The barrier could be left in the Pacific Ocean and naturally dragged around by the currents. As it moved, it swept up floating plastic, funneling it towards a giant retention zone. This retention zone was kind of like a giant sack. When it was filled with plastic, a ship would come in and empty all the contents. System 001 showed a ton of potential, but there was a pretty major flaw. The ocean currents that moved the structure just weren't reliable enough. So in 2021, the ocean cleanup designed a new version that was pulled along by ships. System 002, as this next project was called, was a big improvement. As well as the ships that were used to pull it, it was also significantly larger than the original version. The U-shaped barrier was approximately 800 meters long, as opposed to the 600 meters of the original System 1. In 2 years, the impressive System 002 was used to remove several hundred tons of plastic from the Great Pacific Garbage Patch. But in 2023, the ocean cleanup launched a third version of the project, and it was bigger and better than anything that had come before it. System 03, as this structure is known, has a U-shaped barrier which runs for a total of 2.2 kilometers. That's almost 3 times as long as the previous one. This massive barrier has 5 times the capacity of System 001. With the new version, they want to optimize their cost per kilogram of plastic removed from the ocean. On top of that, they use AI to target the densest patches of plastic in the sea. Overall, the new system is much more efficient, making it possible to build a whole fleet of them to clean the entire Great Pacific Garbage Patch. Now it's time to return to dry land. Next, we're going to take a look at a mega project powered by 5G, the Huawei European Supply Center in northern Hungary. This part of the video is actually sponsored by Huawei. They invited us to their supply center and to see their 5G network up close. For those who don't know, 5G is a cutting-edge approach to network connectivity. It's much faster than its predecessor, the 4G networks that most of us are used to, with the potential to download data up to 20 times faster. With 5G, you could download an entire movie in less than a minute. But that isn't all it's good for. If you connect too many different devices to a 4G network, it usually starts to lag. We've all experienced that, right? But a 5G network has the speed and bandwidth to connect hundreds of devices at once. This creates an opportunity for digital ecosystems, with phones, computers, cars, fridges, watches, robots, and other devices all linking together and sending data back and forth in a complex, high-speed web. Huawei is working at the forefront of this new technology. They're mainly known for building phones and computers, but they also specialize in information technology and network connectivity. After helping to establish 5G in China, they're now looking to do the same in Europe. And that's what their European Supply Center is there for. It's the first private 5G network factory in Europe. Its central location right next to Budapest gives them easy access to important countries like Germany, Italy, and France. Even countries like Iceland are within easy reach. Thanks to high-speed shipping, Huawei can deliver a piece of technology from Hungary to Iceland in a matter of days. So now, let's take a look inside the factory, where we talked with an expert.
Welcome to our Huawei Smart Factory in Hungary. My name is Gergő Mucsányi. I'm an engineer responsible for the new product introduction and the automation development.
When we visited the factory, Gergő showed us around and explained to us how Huawei has incorporated 5G into its daily packaging and logistics operations. For example, they're using a fleet of so-called AGVs, or Automated Guided Vehicles. These robotic vehicles are able to move crates from place to place without needing a human to control them.
These machines are making our warehouse fully automated without manual operation.
So, since there are no employees needed to operate these vehicles, the supply center is much more efficient, while the workers can focus on the more complex tasks. To make sure every spot can be reached, they have 2 different kinds of vehicles.
We have 2 different types of AGVs. The bigger one is supporting the high-rack storage operation in our warehouse. The other type is the smaller one, which supports the ground floor operation and the material transfer within the factory.
Using the factory's private 5G network, these robots are constantly talking to each other, exchanging instructions and making sure to not get in each other's way, just like real workers. They're equipped with a guidance system, a set of cameras and sensors that let them safely navigate the warehouse.
These machines are completely safe and it can work with our colleagues. You see, it's stopped.
But this isn't the only 5G tech that this Huawei supply center is working with. In another part, we were introduced to an employee who is wearing an AR smart glass.
My colleague is doing the optical cabling inside of this cabinet. For this, he have a remote support from our headquarters. An expert sees his work and give him instructions in the small screen on the glass and in the microphone.
If an employee doesn't know what to do with a product, they can connect to a remote expert in China. Through the smart glass, the expert is able to see what the employee is seeing and starts displaying instructions on the screen. Thanks to the 5G network's low latency rates, these back-and-forth instructions feel almost instantaneous, even when the expert sits over 6,800 kilometers away from Hungary.
We can use this smart glass for remote trainings, complex MPIs and maintenance activities.
In addition to this, the European Supply Center has another important feature.
The next thing is the AI camera check, which is an automated quality control solution.
Using machine vision technology, this AI can study any product that's placed in front of it. It compares the product to a so-called digital twin, a kind of perfect model of this specific product that the AI has studied in the past. If the latest product doesn't align with the twin, it will go back to the factory, where all the errors can be fixed.
With this solution, our quality control became fully human independent.
Since installing all of these 5G features, the supply center's efficiency has increased by 30%, and that's why it's no surprise that private companies all over Europe are starting to set up similar automated 5G systems of their own. This is often called Industry 4.0, the fourth industrial revolution, and Huawei's European Supply Center is definitely one of the pioneers in this field. Now, let's move on to a different record-breaking project, the Badla Solar Park. As the world becomes more advanced, our energy requirements are only going up. And with fossil fuels dwindling, not to mention the issue of carbon emissions, lots of countries are turning their attention to renewable alternatives. Earlier, when we talked about the ELT, we mentioned how the telescope is being built at a Chilean desert mountain, where clouds are virtually unheard of. Well, the Thar Desert in northern India is also known for its clear skies. It would be a great place to build another telescope, and it's also a great place to set up solar panels. Since 2015, that's exactly what India's been doing, and they've wound up with a solar park that's larger than a lot of towns. In total, there are 10 million panels, covering an area of 56 square kilometers. That's a third the size of Washington, D.C., and enough energy generation to power more than 4 million Indian households. Badla is officially the largest solar park that the world has ever seen. Badla is home to a cutting-edge fleet of robots, which are used to keep dust off the solar panels. The Thar Desert doesn't get many clouds, but it does have the occasional sandstorm. Instead of relying on human workers, this project uses 2,000 automated robots to keep the panels clean. Now, let's take a trip to outer space with NASA's Lunar Gateway. In 1969, NASA achieved the impossible. They sent a human to the moon. It was an astonishing feat of engineering, with the total cost of the Apollo missions landing in the region of $25 billion. More than 50 years later, they're working on something even more ambitious. They want to go back to the moon, and this time set up a space station called Lunar Gateway. A space station is a high-tech orbital habitat that can support a human crew. They're generally used for scientific purposes, like testing the effects of zero gravity and finding out whether microorganisms can survive in outer space. They can also be used to take satellite-type images. The most famous example is, of course, the International Space Station. To this day, it continues to orbit the Earth like a giant satellite, about 100 meters long and 70 meters wide, spinning around the entire planet roughly 15 times per day. Getting this station up into space wasn't easy. It weighs more than 400 tons, far too much weight to launch with just one rocket. That's why the ISS was sent into orbit piece by piece and then joined together by astronauts. In total, the construction took 10 whole years and just over 30 missions. It's very impressive, but here's the catch. The ISS was constructed at a height of approximately 400 kilometers from the Earth. This might sound like a lot, but not when you know that the moon is on average around 384,400 kilometers away from the Earth. So imagine building a space station at this distance. This is actually the current plan. In 2025, the first 2 modules will be launched into space by a Falcon Heavy rocket. This will be the power and propulsion module, basically some thrusters to control the space station, and the habitation and logistics module, a series of rooms where a crew of astronauts can live. These modules will reach the moon in 3 days and then fall into a steady orbit. A month later, another module will arrive, this time with a team of astronauts. They'll start putting the first modules together, while more modules continue to arrive from Earth. The final piece is expected to arrive by the end of 2031. When it's finally finished, astronauts will use the Gateway to study the moon in more detail than ever before. They can live on the station for months at a time and use it as a staging post for expeditions to the moon. At the closest point of its orbit, the station would be 1,500 kilometers from the lunar surface. Astronauts can also bring samples back to Lunar Gateway's onboard laboratories. They might even be able to turn moon rocks into water using a device that would pull oxygen from iron oxide deposits, then add hydrogen to generate H2O. All in all, the Lunar Gateway would be an amazing achievement, but this still isn't the most advanced megaproject on our list. That title goes to the International Thermonuclear Experimental Reactor. That's ITER for short. This cutting-edge project is a collaboration between some of the biggest countries in the world, including China, Germany, India, France, the United States, Russia, the United Kingdom, Japan, and plenty more. They're calling it the most complicated machine in human history and the most expensive experiment of all time. But what the heck are they trying to do? To understand this project, you need to know the difference between nuclear fission and nuclear fusion. Nuclear fission is what happens in nuclear power plants. A large atom is split into 2 smaller atoms, which releases massive energy. It's a good way to produce power, but it comes at a price. When the atoms split, they become violently unstable and extremely hard to control. Nuclear fusion is different. Instead of splitting an atom, it combines 2 atoms together. This process creates 4 times as much energy. And radioactive byproducts only last around 50 to 100 years, which is very short compared to nuclear fission. On top of that, fuel is basically unlimited. All you need is 2 hydrogen isotopes. One can be derived from water, and the other is a byproduct of the reaction itself. Overall, it's the perfect way to generate energy. Powerful, less waste, and easy to fuel. The only problem is, nuclear fusion is extremely difficult to pull off. It does happen naturally at the center of the sun, but recreating those conditions in a laboratory setting is a completely different story. It's happened a few times on a tiny scale, but never enough to produce any meaningful energy. Maybe enough to boil a kettle, but not enough to power a city. That is what ITER is trying to change. They're in the process of building an experimental machine in the south of France. This machine will require more than 1 million components and take several years to assemble. By the time it's finished, in 2035, it will weigh in at more than 20,000 tons and stand at a height of 30 meters. At the core of the machine is a colossal donut-shaped chamber. It's made of double-walled steel, which is where a lot of ITER's weight will actually come from. This chamber will weigh more than 4,000 tons on its own, and it's where the fuel will be pumped at the start of each reaction. It's big enough to walk around in, but you probably wouldn't want to, as the interior of the chamber is a tightly sealed vacuum. This chamber is lined with heating elements, including a pair of high-energy particle beams. Working together, these heating elements can create an environment of more than 100 million degrees Celsius. That's 10 times hotter than the core of the sun itself, and the perfect temperature for nuclear fusion to occur. When you heat up particles to such blistering levels, they'll start bouncing around like a storm in a bottle, and the steel walls of the vacuum chamber won't be enough to hold them on their own. That's why the machine will use magnetic fields to hold the particles in check. These magnetic fields will come from a set of giant coils. Each one will be 14 meters tall. These magnets are so huge and expensive to produce that they've actually been divided up amongst the different countries that are working together on ITER. Makes sense if you think about it. If all of these components work as planned, the machine will be able to create and maintain the right conditions to set off a fusion reaction. But what ITER won't be able to do is convert the reaction inside into usable electricity. This entire project is a proof of concept, an attempt to show that it's possible on a massive scale. If they succeed, it could pave the way for electricity generation using nuclear fusion. ITER won't turn on for a few years, but when it does, it could change the world. What do you think about these megaprojects? Which one are you most excited about? Let us know down in the comments below. If you enjoyed this longer video, subscribe to Top Luxury. And as always, thank you so much for watching, and we'll see you in the next video.
So let me understand. If we understood that properly, this won't even provide electricity. That mega project is just a concept that if they get that working, then they will devise a way to generate electricity from that concept. That's a major, major undertaking with, well, I guess it's very beneficial as a to test to see if this works, and I'm almost positive that they know it works, or else they wouldn't expend so much assets into that type of project. It's just uncalculable to think that they would expend that amount of assets without being sure that it could work. Yeah. So 2037, I believe they said, is when that would be in effect. And that's just to get that machine to work. They will not be getting electricity from that machine itself. They would have to add add-ons, create add-ons, and I guess re-engineer the machine to actually produce electricity.